So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? Perfect. Thank you so much for the confirmation, everyone. So my name is 𝐑𝐤𝐿𝐴, and I've been working in this IT industry for more than 13 years now. So the agenda for today's session, first of all, we are going to discuss on data structures in Python. And again, in data structures, how we can work with built-in data structures and how we can work with user-defined data structures. And then we are going to discuss about algorithms in Python on what exactly algorithms are, the elements of a good algorithm, algorithm classes, the tree traversal algorithms, the sorting all algorithms and searching algorithms, and then we are going to do the algorithm analysis. All right, so the knowledge of data structures and algorithms forms the base to identify programmers, giving another reason for knowing Python as a language. And while data structures help the companies in making sure that they are able to better organize the data, algorithms help find the solutions to the data analysis problems. So if we talk about the data structures in Python, then first of all, there are multiple types of data. We have the built-in data types, and then we have the user-defined data types. Now, in terms of built-in data types, we have list, tuples, dictionaries, and sets. So lists are used to store index elements that are changeable and can contain duplicate terms. So in a given list, we can have multiple duplicate items, and plus we can modify, update the list items whenever we want. Then we have dictionaries. So dictionaries are like key value pairs that are changeable. That means we can modify them at any point of time. Then we have tuples. So tuples are unchangeable. That means we are considered as immutable. They cannot be changed once we have declared it. And they cannot even have the duplicate copies. And then we have sets. So sets are like continuous, are like unordered unique elements that are mutable. That means here it needs to be, all the elements needs to be unique. They cannot be repeated and they can be modified at later point of time. All right. And then if we talk about the user-defined data structure, then we have stack, queue, tree, linked list, graph, and hash map. So to start with, we have stack. So stacks are like the linear last in first out data structure. So basically, if the elements which has been updated to last is going to be pushed out to first as a last in first out as a LIFO architecture. Then we have queues. Then we have queues here. So queues are like linear first in first out. So the data element which was firstly introduced, that is going to be exited for the first again when the exit happens, and that's how it works on the FIFO part, first in first out. Then we have trees. So trees are like non-linear data structure having a root and a node defined. Then we have linked list. So linked lists are, in simple layman terms, they are data structures that are linked with pointers. Then we have graph. So graphs contain a collection of point or nodes along with edges. And then we have hash maps. So basically they are same as dictionaries if we consider the Python scenario. All right, so now we had to discuss on the concept for built-in data structures, how they are configured. So here we have dictionary, we have sets, we have tuples, and then we have list. So we discussed this list. Again, they can contain heterogeneous data and they are mutable. That means they can be changed. Dictionaries are saved as a key value pair and they are also changeable. That means we can modify and update them. Tuples are same as this, but again, they are not mutable. That means we cannot modify it. And then we have sets and they are unordered collection of unique elements and they are mutable. That means we can modify them. Then we have user-defined data structure. We have user-defined data structures like we have stack, linked list, graphs, hash maps, trees, queues, and stack, where we have discussed about these components in detail. So now let's discuss on algorithms in Python. So what are algorithms? So algorithms are basically a rule or a set of instructions that needs to be followed for completing a given task. For example, if there are multiple ways of completing a task, then what should be the most optimum path? And suppose if they are a condition, then how that condition should be applied. Again, these all things are well defined as a part of algorithm. So they are used for finding the pseudocode for any given problem. For example, if we are writing a problem, for example, the same concept you may have learned back in the school days when we were learning about the flowchart as well. So if we talk about creating a flowchart for, let's say, making a tea, then we had to boil the water. If the water starts boiling, then we should be adding tea leaves. If it is not, then we should continue to boil for a couple of seconds. So the logic, what should be applied at what point of time based on the given choices, then that is what we refer as algorithm here. That is what is referred as algorithm. And which part we are referring to, Anand? And if you talk about the algorithm structure, again, it has to be the most efficient logic, and they basically give the pseudocode for problems and then can be implemented in several languages as they are not language specific. So here we have to figure out the problem first. What exactly is our problem? So algorithms are generally written as a combination of user understandable language and some common programming languages. Now they are commonly written down in steps. However, it is not always necessary to do so. So there are no distinct rules to formulate algorithms, but we will need to keep the following pointers in mind, like we can see on the screen. So we had to first of all figure out what exactly is the problem. Then we had to figure out, determine where exactly we need to start, and then we have to think about where we need to stop as well, because starting and stopping both are required. And then we had to formulate the steps which are going to be performed in near future as a part of the response, and then we have to review our steps as well. For example, let's say we had to formulate a simple algorithm to check if a student has passed the exam or not, right? So here we can create multiple steps algorithm. So here we can start, we can declare two variables, and then we can store the marks and obtain in by X, and then we can store the minimum passing score in Y. And then we can check if X is greater than Y, then student has passed, else it should return simply fail. And now we have to stop the execution as well. So if you want, we can manipulate this example as well. For example, let's say we want to assign the values to variables in step 2. Or for example, let's suppose here we had defined multiple variables for passing and for failing. So you can define multiple variables, and then we can also apply our own logic. We can find the percentage and so on, depending upon the requirement. So if we talk about the good algorithm, so if we talk about the elements of a good algorithm, then they are multiple. First of all, the steps should be finite, clear and understandable. That means there should not be any kind of discrepancy, plus there should not be any kind of confusion for what needs to be done, and that too in what manner. So the entire algorithm structure should be clear. There should not be any kind of confusion of what needs to be done and what needs to be avoided. It should be completely clear for all. Then second, there should be a clear and precise description of input and outputs. So what should be the input from the end users, and what is the output that we're expecting. And each step needs to have a defined output that depends only on input and in that step or the preceding steps. And then the algorithm should be flexible enough to mold it in order to allow a number of solutions, and these steps should be made of general programming fundamentals and should not be any kind of language specific. So if we talk about the algorithm classes, then first of all we have divide and conquer, then we have dynamic programming, then we have greedy algorithms. So these all are different types of algorithm classes. So first of all, divide and conquer. So in divide and conquer, we simply divide the problem into sub statements. For example, we have a large problem, so we can divide it into, suppose, smaller component, and then we can start solving those smaller components one by one. And if all the smaller components are going to be solved, the entire problem is going to be solved as well, correct? So here we can divide the entire big problem into smaller statements, and then we can start working on it. And then we have the dynamic programming. So here we can divide the problem into subparts. Remember the result of the subparts, and we are going to apply it to the similar ones. So here we can try to find a pattern as well. And then we have greedy algorithm. So it invokes taking all the easiest steps while solving a problem without worrying about the complexity of the further steps. So here our goal is to get the entire statement up and running, and then we can further work on rectifying the issues or further work on steering the current data set we already have the access to. So moving ahead with this data structure and the algorithms in Python, we are going to discuss now on tree traversal, on search algorithms, and also on the sorting algorithms being used. So now we are going to discuss on the tree traversal algorithm. So basically, trees in Python are non-linear data structures having a root and nodes, as we have seen here, we are looking at in this current diagram. So basically, based on the order in which nodes are visited, there can be three types of tree traversals. So basically we have three types here. As you can see, we have three types. We have pre-order, in-order, and post-order. So first of all, let's do one thing. Let's start with in-order traversal. So in-order traversal refers to traversing the tree in such a way that we first visit the left nodes followed by the root and then the right nodes. So we begin our traversal in the form from all the nodes in the left subtree, and then we move towards the root and then finally towards the tree altogether. That's how in terms of in-order traversal works. First of all, here we start with the left nodes and then followed by the root on the right nodes, and then we are going to bring our to start a traversal from the nodes in the left subtree, and then we move towards the root and finally the right subtree altogether. That's how it works. And here we can see in this, now to have it as a part of reference, we can see from this given diagram that 4 is the leftmost. As you can see here, 4, this node 4 here, 4 is the leftmost node, and hence that this is going to be the first node that is going to be visited. Next, we are going to move towards the roots. That means, so here now when we are moving towards the root here, so the root for 4 is what? What is the root for node 4 here, guys? Let me just highlight this. The leftmost node is currently 4, right? So what is the root for node 4? It is 2, right? So it is going to move towards the root node first, right? So it's going to move towards 2, and then following that, we must check if we have any node towards the right. And the tree shows that we do have a node as root 5. So then it is going to present to again visit new node 5. And once that is done, then the left subtree is complete. And then we are going to follow the same rule again from the left root right in the order to complete the entire traversal. All right. So again, it is going to go back to the leftmost, that is 4th, and then it's going to traverse to the right available. If we are done with in order, so now here we can work with a pre-order traversal as well. So in terms of pre-order, the root node is visited the first and then followed by the left subtree and then the right subtree. So in this example, we can see the first node visited is 1. So here we can see the first node that we are going to visit is 1, and then followed by the node 2, which is towards the left of the node 1. So the left side is node 2, and that is going to the second path. And again, it is going to move towards the left. Again, it is going to be 4th. And now there is no left. So now we are going to traverse to the right section. And again, from right, again, we are going to go upwards and 3. Suppose there was another element available, then next it would have gone to that particular element as well as a part of the pre-order traversal. And then if we talk about the post order, so post order traversal begins from the left, then to the right, and then finally to the root. So here it starts from the left and then it goes towards the right, again towards left, again towards right, again towards left, and so on. So it's like a complete zigzag path that is followed by using post order traversal. That is going from left to right, and so on. So sorting of data in real time, we can say when we are working on sorting any data, then that should be done in the real time. and it should require a number of sorting algorithms to be solved. So moving ahead with the concepts on data structure and algorithms in Python as a part of a discussion, let's start our discussion on the sorting algorithms first in Python. Let's start with it first. Now, in terms of sorting algorithms, so sorting algorithms are used to sort data into some given order. And sorting algorithms can be classified into 5 types. That is, we have message sort, we have merge sort, then we have bubble sort, insertion sort, selection sort, and then we have shell sort. So all the algorithms are here. Again, they all are going to be defined. First of all, if we talk about the merge sort, let's talk about these sorts one by one. So if we talk about the merge sort, then merge sort algorithm follows the divide and conquer rule. First of all, it follows the divide and conquer rule. So here the given list of items is the first divided into smaller units, and then it reaches a point where each list consists of exactly one item. And by default, a list containing one item will be sorted, and the merge sort algorithm then compared, or you can say simply was going to compare the adjacent lines and reorders them in the desired sequence. And this process is called as the merge sort. And this process is again done recursively until it reaches a point where there is only one sorted list available. And then we have to take care of multiple algorithm pointers as well. So when we are working with merge, first of all, we should check if the list contains more than one items. If it is going to be yes, then divide the item into 2 halves, else the list is sorted. And then if we have to work with the list, then list has to be divided repeatedly until there is only a single element left in each sublist. And then we have to recursively merge the sublists by arranging them into a given order until we get the single order sorted before we can proceed further. Then we have the bubble sort. So bubble sort is basically a comparison algorithm that first compares and then sorts the adjacent element if they are not in the specified order. That is what we refer as bubble sort. All right, and then we have insertion. So if you talk about the insertion sort here, then insertion sorts are, again, they simply are responsible for picking one element out of a given list at a time, and then it is going to place it at the exact spot where it is to be placed. So it simply ensures that nothing is left out of place, and everything is sorted. And then we have insertion. So we have discussed about insertion, and then we have selection sort as well. So basically, in terms of selection sort, so selection sort algorithm divides the entire given list into 2 equal parts. Or to see a small hands-on on the insertion sort before we move to the other sort here, we can refer back to our IDE. Let's do one thing. Let's open up our PyCharm IDE that we are going to use as a part of the hands-on. We can open up PyCharm is one of the most popular IDEs. IDEs refers to integrated development environment. So we can use any of the IDEs when we are, and if we are planning to work on core Python, either we can use Notebook, Colab, or we can directly make use of PyCharm as well. So if we are looking to develop on core Python only, then it is available for free of cost as a community-based tool. And if we are looking to integrate this with other languages, then we can make use of the professional tool as well. All right, so for now, we can come back to our lab here. And here we have defined a complete definition for the insert sort. So here we can define the insert sort by defining the iSort plugin. So here we have defined again for x in range 1, we define the length a. So basically, and then we have defined the element present on the index value as 1. And then we have defined while we have made use of the while loop, where we define where we are going to compare the elements with the next until the last items. Suppose here we define it should be greater than or equals to 0, and the k value should be greater than a is A for J. And then we can define the comparison between each element to the element present to its left, and then we are going to know which item is going to be, again, it is going to become the key by using AJ plus 1, and then we are going to get the end result to whatever we are going to define here by using the ISORT. Alright, so let's see how exactly the selection sort algorithm works, so we can come back to our discussion. Now, in terms of the selection sort algorithm, so basically in selection sort, we divide the given list into two halves. So in selection sort, we divide the entire list into two equal halves, whereas the first half will be the sorted list and the second half is going to be the unsorted list. And at first the sorted list is empty and all the elements to be sorted are present in the unsorted box. And the selection sort algorithms will look at all the potentials, or I can say all the elements present in the unsorted list, and then they are going to pick up the item that is supposed to come first, and then they are going to place it in the sorted list. And if it is going to be repeated, then the searching process, the place at the next elements to the right of the element is going to be part of the sorted list. No problem with it, Amit? So for example, let's say we want to sort the elements for, or we can say we want to sort all the numbers in the ascending order. So we are going to work with the selection sort algorithm, which will take a look at the complete list, and then it is going to automatically select the smallest element, and then it is going to place the element as the first element in the sorted list. And then it is going to search for the next smallest element, and then it is going to place it to the right of the first element, and so on, as a part of selection algorithm, or you can say selection sort. And once we start working, we are going to look at these components one by one. So, and then we have the shell sort. So shell sort algorithm allows us to sort the elements that have been a part of any problem. So again, that's the original sequence. To sort the elements follows the n/2 n/4, but here the sequence is going to be the number of elements present in the unsorted list. For example, let's say if you want to eat 8 bananas, and then the length of those will be divided by 2, that is 8 by 2, and that means we'll be having 4 as a list. And now the first element will be compared with the 11 other elements at the index number 4, and this gap will be produced by dividing by number 4. So first time the gap will be 2, and the elements that is again going to be part of a complete batch job, then they are going to be executed, and finally 8 by 8 1. So all the other adjacent elements will be compared, and they are going to be sorted as a part of the whole process, as we can see here. As a part of sorting, algorithms followed in data structures. Then we have the searching algorithm. So in terms of searching algorithms, algorithms are basically used to search for, or we can say fetch, some elements present in some given data set. And there are many type of search algorithms, such as linear search, binary search, exponential search, and then we have interpolation search, and so on. So for example, if we talk about the linear search, then linear search algorithm is used to successfully search for a given element by comparing it with each and every element of a given array. And it is one of the simplest searching algorithms, but very important to understand is there are some other good sorting algorithms also available. And then we have the binary search. So in terms of binary search, basically we use it for searching some given elements in a sorted way by making use of the decrease and conquer algorithm. So here the key is looked on by the file, comparing it with the middle element, and then dividing the array out of it. So the left half is search if the elements to be searched for is smaller, and the middle element, and the vice versa. And again, it can be vice versa as well. And the appropriate subarrays are again divided into half, and then process is repeated again. And then after binary, we have the further algorithm analysis that we need to do, where we are going to discuss on the theoretical analysis, on empirical analysis, one by one. So we can see a small example here. All right, so what we can do, let's do one thing. We can define a linear search. We can define a linear search. And let's say here define my array n and the key defined. And then here we can define for x in range 0, for x in range 0 or 0, and the key we can define it to be n as a part of the index value. So here we can define range, and the range can be 0 and n. Now in here we can define a simple if statement. If my array where the index value is going to be x, if it is equals to key, if it becomes equals to key, then we are going to return x, and then we are going to simply define return -1. And then we can define my array. So for example, let's say here we define my array, and we can define any number. For example, here we define 12, we define 2, we define 29 and 16. It can be my array. And then we can define the key. Suppose key should be 16. We can define the key to be 16 altogether. And then we can define n should be, now here we are going to find the length of my array that we have used. And then we can define matched. We're going to use the linear search for my array, the n and the key value here. And then we are going to define if matched is 1, or we can define to be suppose -1, because again that's exactly is what we are going to use the linear search for. And then here we can define print. Now if it is true, then it is going to simply mean print key is absent, or key is not, suppose key is absent. We can define key is absent. And then we can define else it is going to print that key is present, and then matched. So this can be a simple linear search program. So now if this is going to be executed, then we are going to see the output being returned to us. So as you can see here, it simply says the key is present, and then it is going to be matched at 3. So key is present at the third index value as a part of the my array. And same way for binary search, again we can define the binary search as well, where we can simply compare the key with the middle element, and if it matches, we can return the middle index value. And if the key of the element is greater than the middle element, then we can search for the key element towards the right of the middle element as a part of binary search. For example, let's say we do one thing. Let's create a new file altogether, demo2. So in here we can define again a binary search. So here we can define a binary search where we can define something for my list and the key. And in here we can define, suppose the index to be 0. And then we can define the r to be a simple length. So here we can define r, which is going to be a simple length. And again here we can define the length of what? Length of my list, and it is going to be -1. And here we can define the matched, where we can keep the value to false. Then we can make use of a while loop. While I is less than or equal to r and not matched, we can define and not matched. Then we can define the middle value to be what? To be I plus r. It is going to be I plus r, and the entire output is going to, again here we are going to simply void 2. Then we are going to define a condition if my list and the middle value for it is going to be equal to the key element that we define. Then if the matched is true, and here we can define match true. Else if key, we can define another condition. If key is less than my list and the middle as a part of the middle value. So here we can define, okay, let's use the square brackets instead of the curly one. So here we can define that value as middle, and in here we can define r should be equals to middle minus 1, and then we can define else condition as I should be equal to middle plus 1, and then we are going to return the matched, and then we are going to print the statement. Suppose here we can print bin search, the entire binary search, and then we can define the array here. For example, here we want to be, suppose the same elements. Suppose here we got 3, 4, 10, 11, and 12. This can be an element, and then we can define, suppose, the other element as, suppose, 56, and then we can use another print binary search where we can define the same element as 3, not 2, 3, 4, 10, 11, and 12. And here we can define, suppose, let's say here we can define this to be, let's say 26. So if we run this again, basically here with the key, now we are going to compare the key with the middle element, and if it matches, then we are going to return the middle index value. And if the key element is greater than the middle element, then we are going to search for the key element towards the right of the middle element, and then, or else we are going to search toward search to the left of it. We are going to search towards the left of it. So in terms of algorithm analysis, again, we can do the we can say a priori analysis, or we can do the posteriori analysis. So basically, priori analysis refers to the theoretical analysis. So the efficiency of algorithm is measured by presuming that all the other factors are constant and they do not affect the implementation of the algorithm. And a posteriori analysis, which is referred as the empirical analysis. So the algorithms, after being implemented using some programming language, is executed on some computer, and that's why in this analysis the actual values like the time complexity or execution time of an algorithm till it finishes the task, space complexity, or the space required by the algorithm for its full life cycle are all gathered. So that's it, what we have as a part of the entire algorithm analysis and discussion that we had to cover. Thank you so much for joining, guys, and have a great day ahead. Take care. Bye-bye.